Welcome. This is review session 14, and we're into chapter 21 on water, electrolyte, and acid-base balance. And in doing this review and in hitting the high points, what I would like to do is run through the figures and some of the tables in chapter 21. So let's start then with figure 21.1 on page 806. And of course, when we talk about fluid within the body, we can initially divide the fluid into two different places in which it's found. And so we have then this extracellular fluid making up 37% of the total fluid in the body. And of course, extracellular then is implying outside of cells. And then in addition to the extracellular fluid compartment, we have the intracellular fluid compartment. And so fluid within cells then makes up about 63% of the total fluids in the body. Looking at figure 21.2, we first of all have again this breakdown into intra and extracellular fluids. And then also in terms of extracellular fluid, we're looking at a graphic representation of relative volumes, relative percentages actually of the extracellular fluid, which is found in various smaller compartments. And taking a quick look then at figure 21.2, recall that most of the extracellular fluid is interstitial fluid, tissue fluid, and then recall also that the other extracellular fluid compartments are plasma, lymph, and transcellular fluid. And then remember, we did also list the 5 different components that make up this transcellular fluid compartment, and so you should be familiar with those also. Figure 21.3, and of course what we're looking at here now are 8 different ions, 8 different specific charged particles. And for each of these, we're comparing its concentration in extracellular fluid versus its concentration in intracellular fluid. And so again, then looking at figure 21.3, looking at the color coding key in the upper right-hand part of the figure. And so when we're looking then at ions which are more prevalent in extracellular fluid, going down now and looking at the bars in which the extracellular fluid line bar is higher, we have then sodium and calcium and chloride and bicarbonate, all more highly concentrated extracellularly. And then the other 4 ions being shown here, and so potassium, magnesium, phosphate, and sulfate are all more highly concentrated intracellularly within cells. Figure 21.4, and recall as you look at this figure, we're looking now at the movement of fluid between various compartments, between various places in the body where we find fluid. And we're looking here at 2 different forces that move fluid from one compartment to another. Taking a look then at the arrow labeled number 1 in the diagram itself. And notice what we have going on here is plasma being forced, being pushed by hydrostatic pressure, and more specifically by blood pressure. So number 1 again, upper left-hand part of the diagram, we have plasma being forced out of a capillary by blood pressure. And blood pressure again is a type of fluid pressure, a type of hydrostatic pressure. And you'll remember then that when we've moved the plasma from one location to another, we've also given it a different name. And so while the plasma inside of the capillary is pretty much the same as the fluid just on the other side of the capillary wall, once it's left the capillary, we now refer to this fluid as interstitial fluid. Taking a look then at the interstitial fluid compartment in the diagram, let's go ahead and follow arrow number 2. And number 2 then is showing a second force which moves fluid from one compartment to another. And here, remember, we're looking at osmotic pressure. We're looking at osmosis. And you'll recall then that at this point in the diagram, the plasma has become hypertonic to the hypotonic interstitial fluid, and so osmotic pressure, osmosis, brings some of the fluid back into the capillary. And then finally, looking at the arrow labeled number 3 right now, and here again, we're back to looking at a type of hydrostatic pressure, fluid pressure, and in this case, it's the pressure caused by the buildup of the interstitial fluid, which is forcing, if you follow that arrow number 3, which is forcing interstitial fluid into these very small lymph vessels. And so again, it's the same fluid, whether we're looking in the interstitial fluid compartment or in the lymph vessel fluid compartment or the lymph fluid compartment. But again, since it's now inside of a lymph vessel, we call the fluid lymph. Moving to page 808 and figure 21.5, and the A part of the figure then showing sources of body water, and the B part of the diagram, lower right-hand part of the page, showing the pathways by which the body loses water. And remember then, I would like you to know, or to be able to find very quickly in your notes at least, these various percentages. And without running through them specifically one by one, let's just notice that when we're talking about sources of body water, we're talking mainly about water that we consume in beverages, the major source of body water, and the second most important source then, water in moist food. You'll recall here, and let's just mention that there is this third major source of body water, and this is so-called water of metabolism, water which is produced by chemical reactions. And so in your notes then, you should have some information, and you should recall when you're going over your notes or when you're looking at this part of the figure, you should recall that we did flip back to a much earlier chapter from A&P 1, and we talked about various dehydration synthesis reactions and several different specific dehydration synthesis reactions that produce water as a byproduct of that chemical reaction. So again, you should be familiar with several different specific sources of water of metabolism. And then again, the B part of the diagram now, in terms of major pathways, major routes of water lost from the body, And again, you should be familiar with the, or be able to find the percentages also. And so without running through all of these, most of the water lost from the body is lost in urine. And the second most important source of loss is water lost through the skin and the lungs. Water evaporated away basically from the skin and the lungs. Table 21.1 on page 809, looking at regulation of water intake. And you'll remember then that when the body loses even a fairly small amount of water, we have within the hypothalamus these receptors called osmoreceptors that are essentially measuring concentration of solutes. And when we've lost a bit of water, the hypothalamus, the osmoreceptors pick up on this, cause us to become thirsty, and of course we drink and we restore the water that we've lost. Looking at water output now, table 21.2, down at the bottom of page 809, and without going into a lot of detail here, recall that whether we're talking about what happens when we lose too much water and we become dehydrated, or what happens when we take in too much water, again, in both cases, it's osmoreceptors in the hypothalamus picking up on this change in solute concentration and causing the anterior pituitary to either increase or decrease depending on its need, but causing the posterior pituitary to increase or decrease ADH secretion. And of course, this then is going to affect urine production in one way or another, again, depending on whether we're dehydrated and we release more ADH, or whether we've taken in too much water and less ADH is released. Let's stop here for this review session, and we'll come back and begin with electrolyte balance with the next session.